This our next problem, no? Medyo madugo dyan ni dire kay taas-taas. So here we have a signboard. No? So this is a traffic signboard. No? Figure shows a steel traffic sign of thickness 1/8 of an inch fixed to a steel post. So mo na siya atong signboard or signage. And then this is our steel post. The post, so ang thickness anin niya is 1/8 of an inch. The post here is 72 inches in height. Cross-section of the post is 2 inches by 1/4 of an inch or quarter of an inch. This is the post. And it can undergo torsional vibration. So we have a torsional vibration about the z-axis. So this is our z-axis, no? Next is or bending vibration. So we have a torsional vibration along the z-axis or bending vibration either in the zx plane or the yz plane. So we have a zx. So this is a z and x. So it may go bending along this direction or along the yz plane katong opposite pod nga direction. And then napo siya torsion along the z. So imagine na lang na siya no nga mo twist na siya dira. Okay. Determine the mode of vibration of the post in a storm during which the wind velocity has a frequency of 1.27 Hz. So, pangitawon na nato niyang mode of vibration na niya. Unsa yung pag-vibrate? Kung ang wind velocity has a natural frequency of 1.27 Hz, no? So, this is our frequency, F. So, yung unit na is in Hz or in cycles per seconds. Assume torsional stiffness of shaft with a rectangular section as given. So this is the torsional stiffness. In addition, the mass moment of inertia of a rectangular block about axis OO. So this is the axis OO. The mass moment of inertia of the rectangular block is given. So mo po ni siya. Given nga mass moment of inertia for the rectangular block. Kani siya diri sa C. So we have also given steel here. Ang steel nga unit weight is 0.280 pounds per cubic inch. And then the modulus of elasticity. And then we have also the modulus of rigidity. Okay, medyo taas, no? Ato na siyang tagsahon. Okay, let's go to the next page. So sa may first na ito buhaton. No, we have the torsional. So ito na, yung ipangayo dire is torsional stiffness. So we have vibration, torsional vibration, and then we have the bending vibration. So ito lang na inote, no? We have the torsional vibration. This is at Z axis. We also have our bending vibration. In what? In XZ plane or YZ plane. Okay. So first is we have a given frequency due to the wind, which is equal to 1.27 Hertz or cycle per second. And if you multiply that with 2 pi, then natin makuha nga 8 radians per seconds. Next, so may next. Kuha na to ang weight ni signboard or design. And then the weight ni W ni post. So, saan na ito pagkuha, ana? Of course, the weight of the sign is just equal to its area times the thickness. We have the thickness. Ang area is, ato pang isolve, dire. So, we have an octagon no, there, no? And then, if you notice, no, the height, total height of the octagon is 30 inches. And then, kani siya dire, this is 8.8 inches. Since this is a regular polygon, makuha na to siya nga side. So, two ways no to get to measure this side. Pwede to siya sa Pythagorean theorem using this one. Or, pwede na sa kanino 30 minus 8.8 inches. Of course, dili, this is also 8.8 inches. So, kani siya dili nga length is equal po siya sa dili. And then, that is equal to 12.4 inches. Okay, so we have a measure of the side. Now, saan man nato pagkuha ang area ani? So, the area of this side is just equal to, so atong first is, pwede na to siya nga buhaton nga, natay rectangle nga dako, and then, so we have a rectangle nga dako, minus dayon aning, kani, this is a triangle. So, our area dahil sa sign is, so area, triangle nga dako, that is just 30 inches squared, minus area itong upat ka gamay nga triangle, that is 4 times 1/2 base times height. Base is 8.8, height is 8.8 inches. So the area of the sign, that will be equal to around 745 square inch. So masolve na nato, we have 745 square inch the area times the thickness of the sign. So the thickness of the sign is pila to? We have 1/8 of an inch. So the weight of the sign is equal to 26.35 pounds. So ano ang to mong kwaon niyang weight? It is because magamit na to na siya sa to ang natural frequency nga formula. Next, you have the weight of the sign. Kanina pod, yung weight na pod ni steel post. So the weight of the steel post, that is just equal to the density times the volume. Naman tayo density gyatag. If you remember, we have 0.283 pounds per cubic inch. And then we just multiply that by the volume of the sign post. That is 72 inches times 1/4 of an inch nga thickness and 2 inches nga width. So we have a weight of the post makuha which is equal to 10.19 pounds. Next, you have the weight of the signboard and the steel post. Next na to kwaon is ang stiffness sa sign post. So the stiffness of this one. So ano man, because we need to get the bending vibration along the XZ plane and the YZ plane. So ako lang next na lang para di kay gubot. So sa to, itong ipangita is torsional stiffness. So na torsional vibration daw at Z-axis. And bending vibration at XZ plane. and YZ plane. Since part mo sa formula na to ni stiffness for bending is, di ba, we have the 3EI over L cube. So, pangita na to ang inertia for the bending vibration. So, we have our inertia along X that is equal to BH cube over 12. This is equal to our base of the signpost is 2 times thickness is 1/4 of an inch cube over 12, or equal to 0.0026 inch to the fourth. So, muna siya, no? This is XX, and then we need the moment of inertia along the XX, and then we have here the BH cube. So, kung tanaw na to yung section ani, sa post is muna siya na kaya ni. We have our B, and then we have our H. This one. Next is the moment of inertia along the Y. So, pabali. So, that will become HB cube over 12. Because on the YY or the YZ plane, yan naman sa lang itsura. You have the B here and then the H. So, mura na sila na-rotate. So, you have the H is equal to 1/4 of an inch times 2 cube over 12. Then we have our inertia, moment of inertia here in the YZ plane, which is equal to 0.17 inch to the fourth. Nanantay stiffness, we have the length, we have the inertia. So, makuha na nato si bending stiffness along XZ plane. So, we have 3EI YY over L cube, which is equal to 3 times 30 times 10 to the 6 Newton per, sorry, this is not Newton, but rather pounds. This is pounds per square inch times 10 to the 6 pounds per square inch times the moment of inertia for the exit plane, that is 0.17 inches to the fourth, all over L cube, or length is 72 inches cube. And we'll have our stiffness along the XZ plane, which is equal to 41 pounds per inch. Then our stiffness on the YZ plane, that is equal to 3E times the moment of inertia on the YZ plane over L cube. We have 3 times 30 times 10 to the 6 pounds per square inch times our IXX is 0.0026 inch to the fourth over the length of the post, 72 inches cube. And eventually we'll have our KYZ, which is equal to 0.63 pounds per inch. So we have our I, we have our inertia, we have our stiffness, bending stiffness. Next is, let's try to solve for the torsional stiffness na sad. Or pwede na sa dato, di po i-solve na lang daan si, bending natural frequency on the XZ plane and the YZ plane. Pero sige, later on na lang. In the next slide na lang, okay? So we have our stiffness along the XZ plane, which is equal to 41 pounds per inch. And then on the other hand, we have our bending stiffness on the YZ plane, which is equal to 0.63 pounds per inch. So our natural frequency for this one, that is equal to the square root of kxz over m. So that is just equal to 41 pounds per inch divided by the mass of what? The mass of the signboard, which is equal to 26.35 pounds, and then to be divided by 386.4 inch per second squared. So here you will have 24.52 radians per seconds. And then natural frequency on the YZ plane is just equal to KYZ over mass. So that is just equal to square root of 0.63 over 26.35 divided by 386.4 inches per second squared. And then eventually we'll have our natural frequency for bending in the YZ plane is equal to 3.04 radians per seconds. Sir, ganong in the previous example, gi-appeal mo to na to ang mass sa bar. Di ba, if you remember before katong gi-punch galing nga metal sheet, gi-appeal na to ang mass sa bar o ang mass sa katong sa tumoy sa system, the tip mass. But this one, ganun naman na to gi-appeal ang mass design post, only the mass of the signboard or of this one, ganun kanina man. Of course, nasa instruction nga dili do apilon ang mass ni signboard. But if ipapil siya, then ato mo siyang i-include sa ito ang calculations. Okay, next, let's proceed with our stiffness. So, natay K, no? The K or stiffness, nato is dali lang nato. So, we have this formula. So, we just write that one. The formula for the torsional stiffness, that is equal to 5.33 pila to 5.33 AB cubed G over L times 1 minus 0.63 B over A times 1 minus B to the fourth over 12A to the 4. So, susunod natin yung value din, we have 5.33, and then our A is the times 1 times our B, which is equal to 1/4 thickness cube times the modulus of rigidity, that is equal to 12 times 10 to the 6 psi or pounds per square inch over the length of our signpost, which is equal to 72 inches times 1 minus 0.63 times our B, which is 1/4 over 1 times we have 1 minus 1/4 to the fourth, the thickness of this steel post, 12 times 1 to the fourth. So our torsional stiffness KT is equal to, we'll arrive at the solution of 1,598 pounds per pounds, inches per radians because this is torsional. So we have already our KT, then eventually we'll be able to solve the natural frequency of the torsion due to torsional vibration. So the torsional vibration or frequency is equal to square root of K, torsional K over, if you remember, we have our polar moment of inertia. So we were given our polar moment of inertia katong IOO, which is equal to KT over rho L over 3 times B cube H plus H cube B. So this was given in the problem. So the natural torsional vibration, we have our torsional stiffness 1,598 pounds inches per radians over the rho. The rho is just equal to the unit weight na 0.283 pounds. So we have our 0.283 pounds per cubic inch divided by 386.4 inch per second squared times our L. So this is rho L. Our L is 72. Sorry, this is the times we have our 30 inches times B cube. So 30 cube times H 0.125 or 1/8 inch plus 1/8 of an inch times cube times 30. And then you just subtract this to square root. Our natural torsional response will be equal to square root of 1,598 pounds inch per radians over 24.73 pounds per square inch. And then eventually we will arrive at the answer nga 8.04 radians per seconds. So if you recall, ang gipangita is assuming the torsional stiff neglect the weight, determine the mode of vibration of the post in a storm, di ba? So that was what we were asked in the first or in the problem. This one we're asked to find the mode of vibration of the post. So sa may mode of vibration yato isulata, we have the natural frequency. Sa katong we have the XZ plane which is equal to 24.52 radians per seconds. Our natural frequency in the YZ plane which is equal to 3.04 radians per seconds. And then we have the torsional frequency, natural frequency that is equal to 8.04 radians per seconds. Yun yung what is the mode of vibration during the storm. So sa may pa kay balo. If you remember, nagatag siya og natural frequency due to wind velocity which is equal to 1.27 hertz times 2 pi that was equal to 8 radians per seconds. approximately 8 radians per seconds. So during the storm, ang frequency ni storm is 8 radians per seconds. Diba nakaingon ko nga, the more magkaduol ang natural frequency sa usa ka object sa iyang surrounding, like here, like, so sa ilang example, we have the wind, last time we have the earthquake, the more pod nga mo sabay sa na siya, the more pod mo kusog iyang amplitude, mas mo bawog siya. So among the three vibrations, the bending vibration and the torsional vibration, the mode of vibration of the signpost during the storm, since ang pinakaduol man diri nga kuan ay natural frequency is 8 radians per second, so katong duol ni 8 radians per seconds, that will be the mode of vibration. Therefore, the natural frequency due to the torsion will become the mode of vibration or the motion. So mo yung motion of the sign pag abot sa storm. Okay?